All right, well, good morning, everyone, and welcome back to another exciting day mathematics. Warm-up number 30 is on your screen, and by now I think you should be able to get all four, yeah? Okay, good. Number one, it says solve 3/2 x minus 2/3 equals 5/6. And you can barely see the bar on the 3/2. Let me put that there. There you go. Numbers 2 and 3 is factor. X squared plus 11x plus 24. And number 3, 9x to the 6 minus 100. Number 4, once again, solve for y, then graph using the domain -2, 0, 1. And the equation for number 1 given is -5y plus 15x equals to 20. See how you do with that? Give you some time, copy and go. All right, let's see where we're at. Number 1. What'd you get for number 1? Let's see. Oh, sorry. Alejandro, x equals 1. Hands if you got that. That is correct. So hopefully you should have multiplied times the common denominator, which was 6. Distribute. That became 18 over 2x minus 12 over 3 equals to 30 over 6. And that became, once you simplify, that became 9x minus 4 equals to 5. And then when you solve, well, you add 4 to each side. 9x equals 9, divide by 9, and that gives us x equals 1. All right, Alejandro, pass someone. Yeah, what'd you get for the factors? Okay, so let's help her out. 24 and, oh, this is 11, sorry. 24 and 11. What two numbers multiply to give me 24 that when you add them give us 11? What is it? 8 and 3. 8 times 3 is 24, so this is x plus 8, x plus 3. Hands if you got that? In any order, x plus 3, x plus 8, okay? Pass someone, Sophia. Pedro, what'd you get for number 3? All right, so let's go through this to make sure we got it. How do we check when we factor? Well, the process, and we're going to cover that once more. Aside from our process for multiplication and division of rationals, is as follows. When you factor, you always need to check 3 things. Is it in standard form? Is there a GCF? And is it a difference of squares before you get to Power Rangers? Therefore, is there a standard form? Yes, from highest to lowest. Is there a GCF? Nope. Is it a difference of squares? Let me check. It's got subtraction. It's a binomial. The last thing to check is to see if I can get a square root of this. Square root of 9 is 3. Square root of x to the 6 is x to the 3rd. How about this one? 10. Was I able to get the square root of both? Yes, it's a difference, so therefore 3x cubed plus 10, 3x cubed minus 10. Guys, and these are going to continue coming your way, so make sure you practice all the difference of squares as much as you can. All right? Pedro, pass someone. Isaiah, y equals what for number 4? You turned out. That was good. 3x minus 4. Hands if you got that. Yes? So domain, let's see, x, negative 2, 0, 1. So my range, pass the one. Hector, range. Negative 10, negative 4, negative 1. Okay, hands if you got that. That is correct. And of course you know how to get that. You substitute these values in here for x, multiply, combine, yada, yada, yada. All right, let's graph. So let me start off with my x-axis. So before, if you already graphed it, that's fine. But let me show you once again how to get started with your coordinate plane. We always start with the x-axis. We're going to need what? Negative 2, 0, and 1. How about for the y-axis? We're going to need what? All negatives. That means that I need a longer y-axis on the negative side than on the positive side. Does that make sense? All right, so that means I'm going to move my x-axis as far up as I can, and I'm going to make it longer from the bottom. So my x-axis is negative 2, negative 1, 0, and 1. Okay. So for these three, yes? Okay. For the y, we got negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. Yeah, I love technology. There you go. Pretty good, right? All right. So let's graph. Negative 2 of x, negative 10 of y. Negative 2 of x, negative 10 of y is down here. I forgot to label my axes. There it is. All right. Next, 0 of x, negative 4. 0 of x, 1, 2, 3, 4. And last, 1 of x, negative 1 of y. 1 of x, negative 1 of y. And then, from left to right, connect your points. Arrows at the end. There you go. And you've got something like that. Okay, good. All right, agenda. Copy this, please. Warm-up number 30. Today we're still working on product and quotients of rationals. And tonight, your home play is 446, 447 evens. Yesterday was odds. Now it's even. Some of you are like, Mr. Q, I did it all. Let's go. So I guess you'll do it again, right? No. Yes, why not? Extra practice, right, Amelia? Right? There you go. That's the spirit. All right. So, and for those of you watching online, here's the code again for Nearpod. If you're not part of our campus or our class, just use that code so you can follow along with the Nearpod. ZGN46, same as yesterday, by the way. And it's the same play sheet, which is the 2 pages that I assigned yesterday, but now evens. Today's evens, yes? All right, so last night's home play was 446, 447 odds only. So get that in front of you. You're not going to turn it in today. You're like, what? What? But what I want you to do is check the one that gave you the most problems and discuss it with your neighbor and see if they got something different as you or if they can help you out with that one. Just look at their work, and then I'm going to go over some of those in a little bit, okay? I'll give you some time for that. All right, good. So they probably got it right and they were helping you out, right? Okay, good. So with that said, get in your notes for today. We're going to go over some of these from the home plate again together to make sure you got the process right. But I'm going to clarify a couple of things because it seems like when I met with a tutoring group yesterday that there still seems to be like some missteps in between that are not part of the whole process that I gave you guys. There's some other things that we need to be thinking through before we finish the entire process. So with that said, copy problem number 5 on the screen on your blank sheet of paper. Yeah, in your notebook, yes. So we got x squared minus 1 over x squared plus 5x plus 4 times x squared over x squared minus x. All right, I'm going to erase the number 5 so that we just focus on that. All right, so now check this out. The process that I gave you for multiplication starts with step 1, which is to factor. Is that correct? And factor completely. The whole thing, not just the numerators, the whole thing. Step 2, we multiply. And step 3 is the giant ones, yes? Simple 3 steps. Boom, boom, boom. Okay? However, every step of the way, let me repeat that again, every step of the way before you get to the giant ones, you need to be looking at each one of these when you're starting to factor with this lens. The first thing you need to check for is standard form. The second thing, GCF. And the third thing, difference of squares. Write that at the top left of your paper, please. Now, hopefully with those 3 things, it's going to help you get through these problems a lot easier, because some of you, like I said, continue to forget to do this scan as you're doing the factoring completely. All right? Now, Mr. Q, what if it's none of those 3? Then the last option is Power Rangers. So let's do this one together. Y'all ready? Here we go. Step 1, let's factor. So since we're going to factor, I'm going to look at the numerator. Standard form, yes. GCF, no. Difference of squares, well, let me check. It's got a subtraction that's different. It's a binomial. Okay, so far so good, so let me check. Can I take the square root of this? Square root of this. So therefore, that is a difference of squares, so we write x plus 1, x minus 1. So the numerator is factored already. So once again, make sure, we still are going through our process, but make sure you're scanning it through here when you're doing the factoring portion, yes? Let's go to the denominator. Is it in standard form? Yes. Is there a GCF? No. Is it a difference of squares? No, it's a trinomial. Therefore, 4, 5. Hopefully that's clarifying for some of you, like, because some of you are like, we're running and all of a sudden you kept kicking that hurdle as you were going through, right? So what 2 numbers multiplied give me 4, and when you add them give us 5, 1 and 4. So my factors are x plus 1, x plus 4. Times. All right, now when you get to these, look up. Whenever they are monomials like this. Who? Not here. Whenever you get to monomials like this, just factor them completely. How can we rewrite x squared? X times x, yes. So look at it. This is a monomial. These are binomials. This is trinomial. So whenever you have monomials, factor them completely. And if it has a number, the same thing. All right, let's go to the denominator. Is it in standard form? Yes. Is there a GCF? Yes. What is it? X. Okay. So, check this out. For those of you that are still struggling with this GCF deal, once you identify what's the same on both terms, watch. I said when you struggle with these, factor completely. And then we said that the GCF is what? X, so we divide both terms by x. So, what's left here? What's left here? That's the way of looking at it in case you're still struggling with GCF, factoring out of GCF. Okay? So step 1 is done. We factored completely everything, yes? All right, step 2. The way of looking at step 2, all we have to do, look up to the screen, is rewrite the numerators together. It doesn't matter how many fractions there are, because if you notice on the home plate I gave you one with 3 fractions. Just write the numerators together, because they're multiplying, right? But always start with numbers first, variables second, and parentheses third. So here we go. Where do I start? X times x, variables first, then x plus 1, x minus 1. Let's go to the denominator. What would I write on the denominator? Start with x, then I got x plus 1, x plus 4, and x minus 1. I'm done with step 2. Some of you are like, but if it says multiplication, Mr. Q, why can't we just multiply? You are multiplying. Isn't this multiplication? Yes. Isn't this multiplication? Yes. So, let's continue. Step 3, giant ones. Yes, x. What else? X plus 1 and x minus 1. What do we have left in the numerator? X and the denominator. X plus 4, and this is our product. Hands if you got that by yourself. Okay, not bad, yeah. Okay, let's go to the excluded value, EV. Now I know some of your home plate, they did not ask you for the excluded value, but what did I ask you to do? Excluded value, yes? Here it goes. For those of you that forgot, here it goes. I'm going to use my highlighter. I'm not going to use this. I'm going to use the original ones. This one, this one, this one, and that one for my excluded values. The original denominators. Check your work to see if you did that. So x plus 1 equal to 0, x plus 4 equal to 0, x equal to 0, and x minus 1 equal to 0. Where did I get those from? From the original, bless you, the original denominators. All right, once you solve, x equals negative 1, x equals negative 4, x equals 0, and x equals 1. You good, yes? Yeah. Yes.
So when there's a single monomial, like the number 9 would be turned at 3 times 3.
Very good question. Ivan's asking, Mr. Q, let's say this was the number 9. It's a monomial. What do we do? Well, it's 3 times 3. Yeah, factor completely. What if you had a monomial in the numerator that looked like this? 12x to the second. Well, 2 times 2 times 3 times x times x. Factor it completely. Yes? All right. So, once again, any questions with the process for multiplication? No. Any questions what we're checking while we factor? No. Make sure you keep that in mind. Make sure you write it on your paper. Let's do another one. Here we go. That was number 5. Let's go to number 7. Copy number 7, please. And it reads 9x squared over x plus 6 times x squared minus 36 over 3x minus 6 times 3 over 4x squared plus 24. Once again, I know some of you already did this, but let's do it again so we can practice together. Here we go. So, I'm going to let you go ahead of me on this one, but here goes the process one more time. Step 1, we factor. Step 2, we multiply. Step 3, giant 1. Okay, but for factoring, what are we checking for? We're checking for standard form, GCF, and difference of squares every time, yes? Okay, I'll give you a head start. So I want you to do step 1, and I'm going to see if I can catch up when you're already in step 2. Copy that, Eng? All right, let's see. Let me help you out with step 1. Here we go. There you go. All right. However, for the first fraction, can you give me the full factored form of the first fraction? Shane. Numerator, what'd you write? And if you got that, that is correct. That's fully, completely factored. How about the denominator? X minus 6. That one's a binomial. Stay together. There's no GCF. It's in standard form, and it's not difference of squares. Okay. The second fraction. Help me with the second fraction. Ariana H. What'd you get for the numerator? X plus 6, X minus 6. Hands, have you got that? Yeah, that's the difference of squares. How about the denominator? X minus 2. 3 and X minus 2. Yes, there was a GCF. Hands, have you got that? All right. The third fraction. Numerator. Oh, Mr. Q. All right, 3. There you go. Denominator. What'd you get for your denominator? Ivan.
4x parentheses x plus 6.
Hands, have you got that? Some of you might have written 2 times 2, which is still fine. But for right now, we're good up to right there. Step 1 is done. Let's go to step 2. We multiply, or we start rewriting it, numbers with numbers, variables with variables, and at the end, parentheses times parentheses. All right, go. What do I write? 3 times 3 times 3 times x, x plus 6, and x minus 6. That is correct. Next, pass someone. Roman, what do I write for the denominator? And by the way, look up really quick. Whenever you end up with this and you're about to rewrite them and you have a binomial like this, just put a parentheses because that is multiplication, yes? All right? Numbers times numbers, variables, and parentheses. No, we just, notice here we didn't distribute, we just rewrote them, right? Okay? So we start numbers times numbers, so that means what? Yes, 3 times 4 times x times, and x plus 6. That is correct. Hands, if you got that by yourself. Okay, good. We're done with step 2. Let's go to step 3. Giant 1. Say never the giant once before we move on. All right, so it looks like x plus 6 and x plus 6, yes, but since they're too far apart, I'm just going to do this. Okay? How about x minus 6 and x minus 6? Yes. What else? The x and a 3, yes. So, what do we have left on the numerator? We have 3 times 3 times x. I'm going to write them out first. 3 times 3 times x. And the reason I rewrite it, because sometimes we miss something, and when you rewrite it, you might see another giant 1. And what do we have in the denominator? 4 and x minus 2. Are there any other giant ones? No. So at this point, I can simplify the numerator. This becomes 9x over 4 times x minus 2. This is my product. Check your work, please, on your home plate. You're like, oh, Mr. Q, I got this. Oh, yes. With your hot Cheetos and everything, you were like all focused at night, right? At 2 in the morning after your gaming, right? Oh, my goodness. Excluded values. Let's see. Do I only use 4 and x minus 2? No, tell you never what we're going to write for our excluded values so we can start solving that. Yeah, hopefully your neighbor said you use this one, the 3, this one, the 4x, and this one. All the original denominators factored out. Alright, so therefore, x minus 6 equals 0, 3 equals 0, x minus 2 equals 0, 4x equals 0, x plus 6 equals 0. So, solve this one, x equals what? 6. Is 3 equal to 0? No. And this one is 2. This one is 0. Yes. So you divide by 4, x equals 0. And this one is negative 6. Now, here goes once again to understand why these are excluded values. Mr. Q, why are these excluded values? Well, because if we substitute any of these over here, especially if I start with this one, check this out. What is 6 minus 6? So what is 0 times this? Times that? 0. That's why we cannot use them or else everything's going to be 0. Thank you. From 1 to 5, how comfortable do you feel with these? Yeah, 5, 5, 5, 4. Okay. So what is the one thing that was tripping us out at home or when we go through some of these? These 4 little steps right here. I mean, 3 little steps. Make sure you have those handy. Write them down on the top left of your work because tonight you're going to be doing the evens. Okay? All right, let's move on to division. Oh, yes. Copy this one. Number 11. It reads, x plus 3 over x squared plus 8x plus 15 divided by x squared minus 25, well, over x minus 5. All right. So, well, there it is. Okay. So, our 3 steps for multiplication were what? Factor. Step 2, multiply. Those never change, right? And at the end, giant ones. Okay. However, this is not multiplication. What is it? So let's add one step. Let's call it Q. For what? No, for Mr. Q. No. Q stands for rationals, right? Quotient. Get it? The answer for a division is a what? Quotient. Yes. So what is the very first thing we do before we get done with the other work? We need to have the first fraction times the reciprocal of the second. That's the very first thing we should do. So here we go. The first fraction times the reciprocal. That's why I put the arrows like this, because we're going to bring this one down and this one to the numerator. So that becomes what? X minus 5 over x squared minus 25. Do we know how to do these now? Yeah, so the only thing that changed was we made it from division to multiplication using this step. So now that we're done with that, let's continue. Factor. And once again, what do we use for factor? Standard form, GCF, difference of squares. And if none of those are true, then you do Power Rangers, yes? All right. So I'll give you a head start so you can factor those out by yourself. Copy and go.
Yes.
All right, let's see. First fraction. How about Sophia? What do we get on the numerator? X plus 3. How about the denominator? X plus 3 times x plus 5. Hands, have you got that? Okay. And notice it's multiplication. Can we put this in parentheses? Yes. Okay. Pass someone, Sophia. X minus 5. How about the denominator? Plus 5. X minus 5. Hands, if you got that? That is correct. And I'm going to put this in parentheses. So step 1 is done. Let's go to step 2. Pass someone on. Andres, tell me what to write for the numerator.
X plus 3.
Uh-huh.
X minus 5.
Yes. How about the denominator?
X plus 3. X plus 5. X plus 5.
Thank you. Step 2 good? Yes?
Yes.
Let's go to step 3, giant ones. All right. We see them? Yeah, the first one is right there. Yes. Yes, you need to rewrite the whole thing exactly as it is. Question was, those of you that are watching online, are we supposed to rewrite both x plus 5? Yes, because we're multiplying the whole thing together. All right. What else? X minus 5, yes? So, do we have anything left on the denominator? Yes, x plus 5, x plus 5. How about the numerator? No, however, check this out. Isn't this a 1 on the numerator and a 1 on the denominator? So what is 1 times 1? 1, yes. You're like, what? Yes. Sure, yeah. Megan asked, Mr. Q, can we write this as 1 over x plus 5 to the second? Yes, you may. All right, from 1 to 5, I'll come to our with division. Okay. So if you notice, it's the same process, yes, except for we just add the what? Multiply times the reciprocal of the second. Okay? Now here's something that I did cover this yesterday, partly, but not completely. Excluded values. Let's see. Which which factors am I going to set equal to 0 in order to get my excluded values? Hopefully by now you said the original ones, Mr. Q, this one, this one, this one, and this one, yes? Not these over here. Okay. So watch. X plus 3 equal to 0. X plus 5 equal to 0. Do I need to write it again this time? No, because we're going to get the same answer. This is the only time you don't rewrite it. And then x minus 5. Hold on. Look up to the screen. Look up, look up, look up. All right. Whenever you get to division, yes, you use these, but you also need the original denominator. You're like, what do you mean, Mr. Q? Let's see. What were my original denominators? this one, and this one. So do we have these? Yes, they're right here. Do I have this one? Well, technically I do because it's here, but if this was a different denominator, then I would make sure that this is factored and I add that over here. Does that make sense? Okay, so make a little note for yourself, asterisk, a heart, Make sure you also include the original denominator, because it's right here, yes? Okay? So, we get x equals -3, x equals -5, and x equals 5. How we doing? Yes? All right. So with that said, you should be able to do the last one by yourself. Yes? All right. Let's go to number 9. Number 9. Copy this. X squared minus 9x plus 18 over x squared plus 9x plus 18 divided by x squared minus 36 over x squared minus 9. Now I know some of you are like, Mr. Q, we only have like 4 minutes left. I know. You should be able to finish this in 3. Once again, reminder, this is division. So that means you need to do one step prior to getting your multiplication and all that. Okay? So once again, number 9 is x squared minus 9x plus 18 over x squared plus 9x plus 18 divided by x squared minus 36 over x squared minus 9. You can do that on your own. I'm going to go ahead and stop the video. But those of you here continue your practice, those of you on video, I'll see you guys next time. Peace.